Hi, welcome to the Olympiad geometry. Let's continue our study on Circumcenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Thank you. So here is a problem. In isosceles triangle ABC, AB equals to BC. CD is angle bisector. O is circumcenter. Draw the perpendicular line of CD that passing through O and intersect BC on E, right? So EO is perpendicular with CD. Draw the parallel line of CD passing through E and intersect AB on F, right? So EF is in parallel with CD. So we want to prove that BE equals to FD, right? We want to prove that BE equals to FD. The first glimpse of this problem is that we already know that BC equals to BA, and CD is angle bisector, right? So which means that we want to find another angle bisector here to make them symmetrical. That maybe give us some more information, right? And another thought is that we already see, I repeatedly talk about this, right? Once we see that a perpendicular line, right, we see a 90 degree, we want to find another 90 degree and take advantage of these 90 degrees so we can have a lot of like 4 points are cyclic, right? And then based on that we can have some information. So for this problem I will talk both techniques, right? We will have two solutions to show that how I think of this, how I seeking the solution, right? Okay. Let's consider the first one. We know that FE is in parallel with CD, right? And we know that BC equals to BA. So we know that this angle equals to this angle, right? Because CD is an angle bisector. Then we can just draw the first thing is that we extend the CD and intersect the circle O on another point. Let's call it G, right? Give me 1 second. Yeah, and we call it G. So we know that CD is an angle bisector, so BG equals to GA. That's a property of the incenter, right? So let's just connect BG here. Let's connect the GA here. We don't know whether it's useful or not. Just try to get as much information as possible, right? So this angle equals to this angle equals to this angle and equals to this angle, right? Because, it's obvious, right? These four angles are equal. So now we know that EO is perpendicular with CG, right? That means because O is a circumcenter of triangle ABC, so that means EO is a perpendicular bisector of segment CG, right? So let's mark this point, let's call it M, which means EC equals to EG. Right, so we got EG here. And we can extend EG, intersect the circle O to another point. Let's call it point H. And we connect BH. Okay, now let's take a look what we can get here. Because EC equals to EG, so angle ECG equals to angle EGC, right? Let's just write here, EM is perpendicular bisector of CG, right? So we got EC equals to EG, which means angle ECG equals to angle EGC equals to. So this angle equals to this angle. And we know that this angle equals to this one, right? So equals to angle BHG, right? So equals to this one. And HC, the arc HC reference to the angle HGC, right? So HGC equals to HBC. HBC. So based on this, we know that BH is in parallel with CG, which is in parallel with EF, right? So these three lines are in parallel. And we know that BG equals to HC, right? BG equals to HC and BG equals to GA. Right. Okay, now we think about the triangle BAC. Let's just draw the angle bisector here. The angle bisector of angle BAC, which let's call it AI, right? Because this point is intersection point of two angle bisectors. Excuse me. So we know that all these angles are equal, right? And now we look at the triangle BAC. Let's call this as angle 1, and these are angle 2. So we have angle 2 here, we have angle 2 here. All of these are angle 2. Right? So we know that angle 1 plus 1, 2, 3, 4, 4 angle 2 equals to 180 degree. Right? And this is angle 1 that's reference to the arc CA, so this would be angle 1. Right? The angle CBA equals to angle CGA. They are all angle 1. And we already know that because the arc GA, so the angle 2 reference to arc GA, right? And angle 2 also reference to arc HC. So arc GA equals to arc HC, or GA equals to HC, which means that HG is in parallel with CA. Right? And we know that these two lines are in parallel, which means angle BEG equals to angle BCA, right? These two lines are in parallel. So angle BEG, let's call this point J, right? So angle BEJ equals to, or BEG equals to angle BCA, right? And because EF is in parallel with GC, that means angle BEF equals to angle BCG equals to angle 2, right? So this is angle 2. And we already know that BEJ equals to BCA, so that means this angle is angle 2 as well, right? Again, we don't know whether these are useful or not. We just find anything that we can find here, right? That's kind of like, because this problem is not a very easy one, so we just make it as a geometry research. So that's the thing we can find right now, right? Okay. So we find angle 2 here, we find angle 2 here. And let's think about this one. So we have actually let's do this way. Let's connect A and H, right? Let's connect A and H. Notice that I'm not overlapping AH and AI, right? So think about that angle in triangle AGH, right? Triangle AGH. We have angle 1 plus angle 2 and plus this angle 2, right? This is angle 2. The angle BAG is angle 2. Plus angle AHG, that equals to angle ABG, right? Which is angle 2. Right? And plus angle HAJ, right? That equals to 180 degree. Right? This angle plus this angle plus this angle plus this angle and plus angle JAH, right, equals to 180 degree. And we already know that angle 1 plus 4 times of angle 2 equals to 180 degree. So we got angle HAJ equals to angle 2, right? Which means HIA are collinear. Right, so let's just redraw it. Okay, these are, we just find that HIA are collinear. Okay, now let's come back to what we have here. We have the BE, and we already know that this is angle 2, this is angle 2, so BE equals to EH, right? BE equals to EH, because angle CBH and angle GHB are equal, right? BE equals to EH. And if we connect to EI, okay, we connect to EI, we know that HIA are collinear, right? We connect to EI. So think about triangle BHE and triangle IHE. Because AH is the angle bisector of angle BAC, right? So we know that HB equals to HI equals to HC, right? HB equals to HI equals to HC. So this side, and this side, they are equal. And we already know that HC equals to GA and equals to BG, right? So equals to GA equals to BG. Right, these three are equal based on the property of the incenter, right? And also equals to GI, right? Equals to GI. That's all we can find. So we know that HB equals to HI, and we know HE equals to HE, and we know that angle BHE equals to angle IHE equals to angle 2, right? So we got that triangle BHE and the triangle IHE are congruent, right? That means angle EIH equals to angle 2 as well, which means EH equals to EI, right? And we already know that EH equals to BE, so EI equals to BE, right? And based on angle EIH equals to angle BAH, right? EIH equals to BAH equals to this, equals to angle 2. We know that EI is in parallel with BA. And we already know that FE is in parallel with ID. So we know that EIDF is a parallelogram. Right, is a parallelogram. So in that case, we know that EI equals to FD. And because we already know EI equals to BE, so FD equals to BE. Right. This problem is from Russia Olympiad computation. So it's not an easy one, but as you can see, we just try to find out whatever we can. And eventually we have a lot of critical milestones, like we proved that HIA are collinear, and we proved a lot of in parallel lines, right? BH is in parallel with CG, HG is in parallel with CA, and we find a lot of angle relations. And based on that, it eventually becomes easy to find that EI is actually in parallel with BA, and EFDI is a parallelogram, so we can easily get the result. Okay, that's method 1. Let's find another method. Let me draw the figure first. We have O here, so let's just find B first, and then we connect this one. I'll explain why I do this. Okay, so this is point B, right? This is A, this is C, and we find the midpoint of arc BA, connect it. That's an angle bisector, and we call this point as D, right? And we know that EO is perpendicular with C. Let's still call this point as G, is perpendicular with CG, and we find the parallel line from E to CD, right? That is F. Okay, remember that I said when we see the perpendicular line, the first thing we should do is to find another perpendicular or another 90 degree and try to relate them together, right? So what we can easily find for a 90 degree here, because we already know that BA equals to BC, and we know that CG is angle bisector of angle BCA, right? So if we just draw the angle bisector of angle CBA, we can find a lot of properties. First is that because BC equals to BA, so this angle bisector has two passing through the point O, and also is perpendicular with CA, right? So this is 90 degree. Let's call this point as N, okay? So it's obvious, right? This is 90 degree, and this is 90 degree. Right. So this point is O, and we call this point to be I, right? Because that's a intersection point of two angle bisectors, and we call this midpoint as M. Okay. So we know that COMN are cyclic, right? If I connect CO here and connect M here, right? Look at, so the angle OMC, right? Angle OMC equals to 90 degree equals to angle ONC. So we know that COMN are cyclic, right? COMN are cyclic. And based on this, if it's not very clear, I just zoom in a little bit, right?